Thank you very much. Thanks, Dean. Thank you very much to WoodSolutions for giving me the opportunity to present on the topic of glulam today. Before we get into the actual topic, I just wanted to say a few words about Hyne as a company. Hyne Timber has been around for 138 years, is family owned by the Hyne family. We employ roughly 650 people. We've got sites across Australia, 2 very large sawmills, one in Tambaramba, New South Wales, the other one in Tuan, Queensland, and further processing plants, also glulam plant, which we will talk about today in Queensland, same location as the Tuan sawmill. And also, since 2015, we've got a CLT business within Xlam, the Xlam business, which is part of the Hyne Group. In Albury, Wodonga, we manufacture cross-laminated timber as well. So the main product for Hyne Timber is structural timber framing and byproducts. But as I said, glulam is a big part of it as well, which we'll dive into today. And we've been making glulam at Hyne for 42 years in Maryborough, Queensland. Only just recently, we've expanded our glulam manufacturing capability, and we've added a new plant just on the same site next door to the existing plant. So yeah, we will go into the topic now. I will be talking about a range of areas within glulam. First of all, what is glue-laminated timber? I want to get into a bit of detail in the manufacturing process. I will explain that on the basis of our new glulam plant. Then into products, uses and properties of glulam, applications, and in the end, just some further information for you to get your hands on when you need it. So glulam, from the log to the finished product, as I mentioned, we've got sawmills. So one of our sawmills is located at Tuan, basically at the edge of a large plantation forest, the Tuan forest. So we source and buy our logs from that plantation pine forest. They're then sawn at the Tuan mill, Hyne Tuan mill, and boards are then, as a next step, once we've got the sawn boards, they are dried. They are then stress graded, so we obtain a strength and stiffness grade. Then before transporting those boards to the glulam plant, we have the opportunity to treat, to provide a durability treatment on the feedstock for the glulam to either hazard class 2 or 3 level, which is through a vacuum pressure impregnation. So at that point, and that actually is done on most of our glulam feedstock for Australian use. So once that is done, the treatment is done. The timber boards are then transported in packs to the glulam plant in Maryborough, Queensland, Australia, not far from the sawmill. And from then on, of course, unloaded, and we actually enter our manufacturing process, which I will go into in quite some detail now. So you can see here the layout and floor plan of our new manufacturing site, which is located next to our existing plant. So packs of timber from our sawmill arrive here at this area. You can now follow my cursor. They are then taken onto these rollers and destacked via a vacuum destacker, which is this portal here. So basically, laminate boards are separated out into the process from here. At this point here, where my cursor is hovering, there is an operator marking defects to be docked out of the boards. We dock out these defects because they may compromise the structural integrity of the final product. So that can be large knots, resin pockets, and grain deviation, anything that could compromise structural integrity of a glulam beam. The marked boards then shoot down this conveyor into the docking saw. This docking saw picks up the mark, cuts out the defects, and from there the boards, which are now clear of defects, are packed up. They are then in packs transferred down this way, take a U-turn down this way into the finger jointing machine. Finger jointing is a means of joining those individual short boards back together to make one long board, or laminate as we call it in glulam jargon. So here is one end. The packs are machined on one end, then on the other end, and at that end the glue is applied to the finger joint. The boards are then shot down this line and pressed together. The finger joints are joined together, pressed, and then come into this curing deck. That is where the glue will harden in the finger joints. Here we've got two decks, an upper and a lower deck. It's a bit hard to see, but the reason for that is that means we can actually store two different grades, two different strength grades of laminates to then compose the beams. So that at that point, once those boards are cured, they're all waiting here to be used and assembled into glulam beams, and they come down depending on what beam you're manufacturing at the time. A certain number of inner laminates, which are typically lower strength, and outer laminates, which are higher strength, are then taken from these decks and gone down through this planer to create a clean surface. Glue is applied down here. Those laminates are then going into this press. You can see here, this is it's in cross section a cube, a square, and on each face of the square there is a press segment. So we've got 4 press segments, and the whole thing can rotate clockwise. Each press segment is 1.2 meter high and 13 meter long, and that basically makes our maximum beam size, determines the maximum beam size we can do in this press. So once, I'll go into a bit more detail on that press later. The finished beams come out this way, go through a calibration planer here, which makes the beam square. They can then remove glue as well, and they can then go through this machine here, which enables us to make 2 out of 1, basically get a large glulam beam, split it through the middle, and create 2 beams. The beams then go through this finishing planer here, transfer over here through the docking saw, and labeling is printed on automatically here, and then they exit through here. So that is, I hope you could follow that, and that is the typical process in manufacturing glulam, and it's what we do in our new line in Maryborough, Queensland. Here a picture of the finger jointed laminate curing decks, A and B. As I mentioned, we can have 2 different strength grades. You may be able to see these white lines here. This is glue that's squeezed out, so that's where the finger joints are. Once those finger joints are cured, the laminates go under this glue applicator head. Glue is applied here. You can see here the glue supply line, which is nicely insulated, and even I believe has a heat tracing element to maintain temperature, which allows us to keep a constant viscosity that is important, so that we apply the same amount of glue throughout the year and throughout the different seasons. Those laminates you can see here, they have already gone through. You can't see the glue because it's definitely on. It's a transparent, relatively transparent glue. It's a polyurethane adhesive. laminates then go over here. They are flipped onto the edge, and with that process, the glulam beams are assembled. Then once that's done, they are then pushed under the press. This press segment facing down here is empty. That was emptied before. The glulam beams are then lifted into that press segment. The clamps are actuated, and at that point, pressure is on. The process continues, and the press will turn clockwise. And these beams here in this press segment will then be taken out once that's facing downwards. At the exit, the beams are put in packs, and this is how we deliver glulam to our customers, our own warehouses, merchants. You can see here, these are relatively small beams. This is a new product that we're currently launching, LGL Plus, and I will explain a little bit more about that later on in the presentation. So moving on from the manufacturing process to products, uses, and properties, at Hyne, we separate our approach to the market into two segments. Number one is the residential construction. So residential homes have glulam in it, in lintels, bearers, joists, rafters. And that is for us a commodity product, which we stock in various sizes in our own warehouses. We sell it through merchants and so forth into that market. This is a big market for us. Commercial market, we approach in terms of supplying glulam into the commercial market. We approach through XLAM, a business of the Hyne Group. XLAM is a company that designs and provides design, construction, service in mass timber into the commercial market. So that can be multi-race civic buildings like this one. So in terms of glulam, commercial mostly means, most often means that the beams are not standard size. They are larger section timbers and can be curved as shown in this picture. I'd like to just go through our product portfolio. You can see here in the left-hand column, this is the name we at Hyne give our products. Beam 17 is in terms of the grade, is a GL 17 according to the Australian standard. So AS 1720.1, the Australian timber design standard, specifies the glulam grades, the standard glulam grades. And the number 17, that represents the modulus of elasticity or stiffness of the beam. It is actually the mean of a beam of a tested population. The GL17 is a pine beam sourced from the timber sourced from the Tuan plantation forest, sustainable plantation forest, and it's a very strong and stiff beam, arguably the strongest pine beam globally. It is therefore suitable for high loads, long spans, of course, commercial as well as residential applications, indoors and outdoors if durability treatment is applied. We have a new product, I mentioned it, which is a successor for the existing or the old LGL that we used to sell, and the new product we call LGL Plus because it's an upgrade in many aspects. This is actually not a standard grade. It is possible under the Australian timber design standard 7020.1 for a manufacturer to create a proprietary product and publish the properties. So this is an equivalent GL14, meaning again, 14 represents the MOE, 14,000 megapascal, and that is derived in a 4-point bending test. This product is we aim at Hyne, we aim at mainly the residential market, floor systems, rafters, lintels. The size range is limited, and it's a product that's exclusively manufactured in our new plant. On the hardwood side, we've got Beam 21, which is our hardwood beam made from Queensland hardwoods, and it also is a proprietary product. 21, very, very high E value, therefore suitable for high loads, very high loads. Also, but durability is important because it's actually using a naturally durable timber, the Queensland hardwood, and it has a very beautiful appearance with its chocolatey brown color. So also a perfect appearance grade product. We do supply specials depending on on the grade required and timber resource we have available. We can make those special grades as well. In terms of the size range that we offer, Beam 17, so I'm talking about our commodity product range here now. Of course, they can be used in the commercial application as well, but if we go into commercial, we can do what we call specials down here. Basically, our largest section, 260, that's the width of the beam, and up to 1200 or 1.2 meters in height. And in terms of the length, that will be up to 15.6 meter. Commodity products, they come in standard widths, 65, 85, 130. Depth ranges from 130 to 590. Set depths and lengths 2.4 to 15.6 meters. Again, in 300 millimeter increments. So a huge range of glulam products we stock in our warehouses, and our customers, the merchants, have on stock. LGL Plus, slightly smaller sections, relatively slim product. The smaller one is a 44 mil wide product and a 65 mil product, and ranging in depth from 90 to 360, up to 12 meter long. Beam 21, you can see here, 65, 85, 120 to 600. All these products are supplied straight, and Beam 17 and 21 are also available cambered. In fact, in the residential market, they are typically specified cambered because that cambering has certain advantages. So the cambering means basically an upward curve is introduced into the beam in the manufacturing process with the purpose to compensate for dead load deflection. So once basically the load of the structure is on that beam, the design load of the structure is on the beam, that curve will be no longer there, the beam will be straight. So because of that, a cambered beam outperforms a straight beam of the same size. If in the same application a straight beam would be specified to aim at the same deflection limit, that beam would have to be a larger section, larger depth. Obviously, with this upward curve, the beam has to be installed the right way up, for which purpose we mark it clearly on either of the edges. I want to go into appearance grades. Our manufacturing standard in Australia, 1328, stipulates 3 different appearance grades. That's appearance grade A, appearance grade B, and appearance grade C. We mainly in Hyne, and I think that that is for all, that applies to all Australian manufacturers, manufacture appearance grade B and A. In terms of timber use, it's obviously both pine and it applies to both pine and hardwoods. Appearance grade B, the finish of the beam is a dressed finish. It's gone through a planer. It's a clean dressed finish. which means for painting it's paint ready, but it may need some minor patching on the side. Possibly, you know, some knots have some cracks in it that may need to be patched up. This product is therefore suitable for painted applications, concealed applications, of course, but also exposed where natural timber appearance is acceptable. It is, after all, timber is a natural product, and I personally like to see the timber the way it is and it's grown. Appearance grade A is a step up. It's almost furniture grade appearance. It's not only planed, but it's also sanded. All little blemishes, voids are filled and repaired by the manufacturer. And therefore, this product obviously comes at a higher price. We have a lower recovery of the timber because we cut out more than we do on the appearance grade B, and all the sanding and repairing is labor intensive. This product is used for exposed applications where a very uniform appearance of the glulam is very important. I would call it, personally, it's an enhanced timber appearance, because we've actually, you know, removed some of the natural occurring blemishes. There is also an appearance grade C, structural grade, which allows for any blemishes and voids, so long as the structural integrity of the glulam beam is not compromised. I'll just show you a couple of images, a couple of examples of these grades. This is an appearance grade A beam. You can see here. You can see this. It's been stained. Very little knots, a few knots, and they're not big knots. It's a very uniform appearance on these beams. Going to appearance grade B, structural, you can see we've got bigger knots, and you can see there's some blue stain in this timber. It's a natural occurrence, blue stain. It has absolutely no negative effect or impact on the structural integrity, and it's part of the pine timber. This is raw in construction and could be stained, which would probably take away a little bit of these blemishes. Appearance grade C, an example of our old LGL product, which is that's an appearance grade C. You can any blemishes are allowed as long as the structural integrity is not compromised. You can see roller marks here from machining. It's gone through our machines. It also, you know, allows for blotches of glue. You can see there, and then sometimes you get skip dressing. That means that not all the surface is planed, dressed clean. There may be some areas that show actually the rough sawn timber. Right now, this product is in the process of being replaced by our new LGL Plus, which is manufactured in our new plant, allowing us, also using different feedstock, allowing us to make this new LGL Plus actually an appearance grade B. So Hyne, by phasing this one out, no longer manufactures an appearance grade C glulam product. So this elegantly brings me to a quick mention of our new LGL Plus, which is a glulam beam specifically aimed at offering a cost-effective solution for residential construction with outdoor durability. So this product is, as a standard, H3 treated, can be used indoors, outdoors, decay and termite resistance, for decay and termite resistance, and it's obviously got a very different appearance to the previous LGL, which you just saw in the previous slide. It's got a really clean surface, clear glue lines. We're not using the dark resorcinol glue. We're using the clear phenol the clear PU glue. Here's an example of a primed application of this beam. Externally, used as a gazebo structure in this case. In terms of the grade, I've already mentioned it very briefly. The product, this is actually the range of GL grades as given in AS 1720.1, the timber design standard, Australian timber design standard. And our proprietary LGL Plus fits in just above GL 13, which is a standard grade. As I said, LGL Plus is not a standard grade, it's a proprietary grade. So it fits in here. The old LGL used to be a bit lower, equivalent to GL 13. So we've got here LGL Plus with a 14,000 megapascal MOE. The product is, as a standard, H3 protected. Therefore, it's decay and termite resistant. So it's gone through a vacuum pressure impregnation process, and it can be used for that reason, of course, indoors, but also outdoors in decking structures, gazebos, and the like. Just a quick reference on where different durability requirements are used. So H3 above ground, exposed to the weather. So this column here would be a typical H3 application. It can't be in ground. H3 treated timber can't be used in ground. That would have to be a H5. H2, which we do also in Hyne, a lot of our glulam is H2 treated. That is internally used, and it's resistant to termite attack. Just on the applications for the LGL Plus product, as I mentioned, it's a smaller section product. We do only 44s and 65s and up to 360 deep beams. It's mainly aimed at lintels, bearers, floor systems, whether it be for the outdoors or indoors, subfloors, rafters, and roof beams. Now I'd like to quickly show a short video on with do's and don'ts, some advice what can, should, and should not be done for timber glulam in external applications. And that, of course, applies not only to the LGL Plus, but to any glulam that is used externally. Note that this video is for LGL Plus, but it's really a universally applicable do's and don'ts video.
Okay, some of my BFFs have been SMSing me asking WTF's the difference between using LGL Plus versus plain old LGL or even LVL. And OMG, I am sick of having to spell it out for them. So, my message to them is follow these do's and don'ts, show your LGL Plus a bit of TLC, and you'll be LOLing in no time. Here goes. Do use LGL Plus where long spans are required, but don't forget to measure your span first. Where were we? Oh, do use LGL Plus outside because it's H3 treated and great in wet and humid SOS conditions. But don't forget the finer detailing, especially end caps, drainage and ventilation. Oh, just got another TXT from Robbo saying don't forget top edge capping. That's TEC for short. Yeah, thanks RM. Now, do remember to paint LGL Plus if you're using it outdoors. Oh, and don't be tempted to the dark side. Lighter colours prevent heat uptake, and besides, timber is the new black. Do feel free to hammer your LGL Plus till you've nailed your kid's pinata, but just don't... Oh, for the love of PPE. Do remember you'll need to repaint or seal any cut ends, notches or drill holes with a sealant product like Texture or similar. And remember, don't go XXL with your SPs or your TCs. That's surface penetrations and taper cut. Lastly, do keep it undercover on site, and FFS, be careful with it. Don't do anything stupid that could damage the treatment. So, there you have it. LGL Plus, easy as ABC. plus XYZ. Ah, GGF. Okay.
There you go. This video is also available on our website. You may want to watch it again. It's a bit busy and quick, but very important to stick to those rules when specifying and installing glue laminated timber in outdoor structures. You can see here a good example of top edge capping on this beam, painted. The painting needs to be maintained. On decking joists, they need to be also need to have a capping membrane over it. So very important information, and more detailed information can be actually downloaded from our website. We've got technical data sheets addressing this in detail. Which brings me to the last slide. For more information, go to our website. We've got, if you're interested in the feedstock, the timber, the plantation pine, where it's sourced, or the hardwoods, you can find chain of custody certificates on our website in this link here. Technical data sheets, all about how to use timber, glue laminated timber here. Our website with further information, of course, and don't forget the Hyne design software to specify our glue lamp, but also any other, many other engineered products available in Australia. So that's it from me. Thank you very much for your patience, and over to you. If you do have any questions, would like to contact me, please send us an email on info@hyne.com.au. Thank you very much.
Okay. Thank you, Stefan. We've got some questions coming through, but it's great to see, particularly the manufacturing side of it. You know, a lot of the times we see these wonderful timber products, but to actually hear about how they're made, it's you know, very interesting, and yeah, it's great insight. You know, glue lamp beams have been used in the residential market for nice exposed beams, as well as the lintels. You know, been used for you know, in the commercial side for portal frames and things like that. Now we're starting to see it into more the larger buildings with post and beam type situations for the offices and things. So yeah, it's a whole range of areas. One thing I'll just point out there as well, with when you're mentioning the different sizes, depending on the minimum measurement, where you said some of them are 44, 65 and 85 and then up, anything that's over a minimum of 75 millimeters falls into the mass timber area. So a lot of people, when they're thinking mass timber, they don't realise that GLT is one of those products. Before we get into the questions, I'd just like to also ask myself, with your technical data sheets that you have available on your website, that includes the proprietary products, because they do fall outside of the scope of AS 1720.1?
Yeah, because we're touching in those technical data sheets on areas that are applicable to any glue lamp product. So the proprietary products, they are only proprietary in terms of the sizes as well as strength and stiffness. Yeah.
I've used the Hyne software as well, and it's a great tool if you're wanting to design up a beam or a rafter or a floor joist or something like that. So you can go in and pick the different grades of material. So I don't know if you can actually see the questions there have been raised there, Stefan, but Michael has asked one: would you ever recommend using GL products adjacent to pools? Would a beam 21 be suitable?
Yeah, absolutely. You know, it's follow those the advice. If the top edge is exposed, you know, make sure that there's capping over it. Have use treated if it's a pine beam. Make sure it's H3 treated. It's above ground according to the standard. Follow all the advice and have it painted and maintained. You know, recoat every now and then, and then absolutely it can be used next to a pool.
I think taking that one step further, you also need to be careful of the connection details. You know, make sure that the brackets or the bolts and screws and everything have the right sort of durability as well.
Yeah, no standing water. Avoid having any standing water. It's got to be ventilated and well drained, because that can then initiate decay in those areas. And also, as seen in the video, cuts need to be sealed. So basically, just to make sure that in case there is a little less durability treatment in the center of a beam, while it's fully, the full section is impregnated, it's a bit of a belts and braces approach that those cuts and drilled holes need to be sealed.
Yeah.
But yeah, look, there's a full range of advice in our technical data sheets, and maybe if you watch the video slowly, that'll work as well.
I think it's very important on the durability that you need to design for the durability. Also, I'd like to remind people that WoodSolutions have some fantastic technical design guides, and there's one of those on durability. I think it's number 5 offhand. So yeah, a lot of information out there.
Absolutely.
Next question down, Justin was asking about the cambering limits. Are there minimum, maximum cambers that can be achieved, or is it a set radius that you build into the beams?
Yeah, good question. Camber is a set radius. It's 600 meters. So from memory, on a 6 meter beam, that makes 7.5 millimeters upward deflection in the center of the beam. Yeah, so that's we can do curved beams, but the camber is a set radius of 600 meters.
Yeah. So I guess when people are wanting to specify, they would need to clearly specify that it's got to be a cambered beam if they're wanting to use that.
Yes, and that can be done. For example, in our design software, you choose either straight or cambered, and it will then give you a different section size. Because of the advantage of the camber, you may get away with a smaller beam.
Felix has also asked here, did you encounter any differences in the bonding strength between treated and untreated timber? And would the treatment affect the curing of the adhesive?
No, it does not. No, because we let the laminates flash off for a long period of time after treatment before it's then processed in the glulam plant, so that the timber as well as the treatment in it is stable by that time.
There was one that's just moved. Graham was asking, why does the LGL Plus have to be painted in external use, assuming the component timber sections are treated to H3?
That is just to ensure like an additional measure to make sure it doesn't have to be a paint. It can be a clear coat if you wanted to show off the timber, the natural timber appearance. A clear coat would be sufficient, but it does help if it's exposed to rain and sun without coating, it may start splitting slightly. The timber, not the glue lines, the timber may start splitting a bit, and the color will change as well. So what a coating can do is also it can help maintain the original appearance of the glulam beam.
Right. Richard Smith is going into a bit of engineering detail here, asking about the creep factor. He says, Hyne, in contrast to other glulam manufacturers, use a J2 factor of 1.5. I'm interested to know why you arrived at this. AS1720 only uses J2 factor of 2 for all timber products.
Yeah, that's in AS1720. That's a generic for generic glulam grades. While at Hyne, we've years and years ago, we've actually made our own engineering judgment based on a lot of testing that a 1.5 creep factor is suitable. Once you step outside into external climates, high humidity climates, that factor also for Hyne glulam goes up to 2.0. I also think that some other manufacturers, if not all, have the same creep factors. I believe that GLTAA is also has got a document on the 1.5 creep factor for low humidity applications. That's an important factor. to understand.
Yeah,
so it's based on testing, I guess. It's based on experience and testing.
Yeah. Thank you. Graham's got another question here. How is the current supply availability of GLT? We've found that GLT beams were not available this year.
Yeah, we had some issues due to feedstock availability, timber availability, especially out of our Tuan forest. You can imagine that they're big plantation forests, and the plantation operation, that's not Hyne. We buy the timber from them, the logs from them, and they move around to different areas. And we must have hit an area of, where they harvested an area of forest that had slightly lower mechanical properties, which then made it really difficult for us to actually manufacture the GL17 beam. Because that's such a high stiffness and strength, the GL17 beam, that really that can only be achieved by using this Queensland plantation resource, which is a hybrid between slash and Caribbean pine. We call it the southern pine, with a quite a high density of around about 650 kilograms per cubic meter. So that situation is long story short, that situation is improving now. And yeah, it's very unfortunate for us and our customers that we had some shortages on the high grade beams. Situation is rapidly improving now that we're getting good lots coming through.
That's good to hear. And I guess you're also commissioning the new plant as well.
Yes. It was really bad timing, that's for sure.
Moss has also asked about the special size range. What is more economic, using the exact size required, or are there some standard special sizes?
Standard special sizes. It's always more economical to buy from the shelf. If you want to have a straight beam, I'd recommend to go to our website and have another look at the standard size range we have. But, we can, as I said, we can do up to 260 wide and 1.2 meters deep beams, big beams as well, and long lengths. So it is treated as a special, and therefore pricing will likely be slightly different as well.
Yeah. I have noticed there's been a couple of questions being posted in the chat area as well. So we're mainly just looking in the Q&A. So I'd just like to ask people, maybe if you can just type it into the Q&A session so that we'll get a chance to get to your questions. John's asked here, with longer spans comes increased bearing stresses. Any smart detailing to go with these high stresses?
Yeah, sure. Talking shear in that case, bearing stresses. Yeah, look, there are many options, and I'd recommend to probably involve some timber engineers that could help here. But you could use steel bearing plates, hardwood bearing plates. That kind of approach would work too. I think it's the question to avoid crushing of glulam beams. So hardwood bearing plates would help, and maybe glued in hardwood laminates. That's as a special, we can have a hardwood laminate, for example, if bearing strength was a huge problem. But most often, I think it's actually the problem is solved in the connection using steel connectors.
Yeah, I think there's been some very good examples, like as a column situation, like in the mid-rise market, where rather than just relying on the column bearing onto the floor slab, you're transferring the load directly from the column above to the column below. So there are some proprietary products out in the marketplace that.
Yeah. Other options, screw reinforcement is an option. That's your specialty beam. There are lots of products out there that can actually help solve such issues.
Sophia's also asked, is Australia the largest market of Hyne timber, and what are the top 3 export countries?
It is the largest market, and we export into New Zealand glulam. That's the only export market for us at the moment.
Right. Yep. Just having another quick scan through.
Probably, actually, I may, if that question comes from a Pacific island, I'm not sure. We probably would have, exported into the islands as well. Yeah.
But I guess in that regard too, with you did mention that particularly for the residential market, that you have a number of suppliers out there, wholesalers out there that sell your products. So yes, if somebody is specifying some glulam, what should they be doing? To particularly if it's one of your proprietary products, how should they go about specifying it?
So, look, our Hyne design software has all our products in it, of course, and that's the way to specify it. But other, for example, frame and truss supply nail plate manufacturers have their software. MyTech, Prida, Multinail, they have our software. Our products in their software also, so it can be specified through those software packages. And once it's specified, obviously we do our best that the product is actually available through the merchants and if it's commercial direct to X-Line.
All right. Yeah. I've just had a quick scan back through the chat, and as I said, there was a couple of questions put into the chat earlier. So Mario was asking, with the LGL plus used as floor joist, what will be the maximum length that can be used without blocking? I realise that there's different depth, hence maybe an example will suffice.
Without blocking? Oh, goodness, that's getting into the details a bit. I'm not sure. I don't know the exact answer to that question, but it needs blocking like any other beam to prevent buckling. So, and that would be depending on the height and the thickness of the beam. Sorry, I can't answer that from the top of my head.
No, that's fine.
Getting a little...
Yep. And also, there's been one asked about the characteristic strength that you show in the tables. Is that the maximum strength the beam can reach, or are they reduced safety factors?
Yes, all strength is highly reduced. That's actually 5th percentile. Based on testing to destruction, 5th percentile values. Well, I did mention also that the MOE is an average factor, an average value of a tested population. But strength is different because that is obviously affecting or resisting collapse of a structure. And there we work on a 5th percentile. Stiffness is the average, because that is not a life and death situation. I guess it's a serviceability factor. How much does a beam deflect in service?
Just a couple of other comments that have come through. Matt Smith has said that the blocking is in A1684, and Rob Mansell's also said that end blocking required to all floor joists and roof members.
Thank you, Rob.
Okay, I think we've just about covered most of the questions that have come through. So now's the time if anybody's got any last minute questions you'd like to ask. Otherwise, we might start winding up. And basically, thank you for a great presentation, Stefan, and that was very interesting. As I said, hearing about the manufacturing side of it and seeing what actually goes on. A lot of people see these fantastic products, but you don't realise that the amount of investment that the timber companies go into into producing these fantastic products. So just like to move on to next week. Again, don't forget we have the WoodSolutions webinars on a Tuesday, and on the mid-rise advisory sessions on Thursday. Next Thursday, we're going to be hearing about the Ho Vienna. It's a case study on an 84-metre tall hybrid timber tower. That's to give you a bit of an indication there. The NCC in Australia has deemed to satisfy solutions for 25-metre effective height. We're talking here an 84-metre tall hybrid tower. So that's quite tall. So Tyson Infante from Hyne Timber will be going through that with us. I'd also like to remind everybody to please go to the WoodSolutions website. Lawrence Ritchie has done some fantastic videos which go through the growing, the manufacturing. There's a session there on cross-laminated timber on LVL, so it's very interesting to have a look at those videos. We also have some fantastic podcasts. Adam Jones has put together these, and they're fantastic. And these are just some of the recent people that we've had on these podcasts. They're very inspirational to listen to. So thank you everybody for tuning in today, and we look forward to seeing you at the future WoodSolutions Tuesday or Thursday webinars. Enjoy the rest of your day. Thank you.